Hello, PLP Geometry. Welcome to the second lesson in Unit 5. So again, we are in Unit 5, which is about parallelograms and the coordinate plane. Parallelograms and the coordinate plane. And this lesson, lesson 2, is all about parallelograms. Parallelogram. Right, so again, these are quadrilaterals. They are four-sided figures. They have special properties, and we're going to list out those properties today, right? But let's start with the definition. Now, hopefully, in the word parallelogram, you see that word parallel, right? So a parallelogram okay, is a quadrilateral, that means it has four sides, so a quadrilateral, which means four sides, with both pairs of opposite sides parallel. And I'm going to underline this twice, right? Opposite sides parallel. That's the big deal. That's what makes parallelogram. Opposite sides are parallel. So what a parallelogram looks like, it looks like a rectangle, but kind of slanted. So I'm going to draw it like this. There we go. When you name a quadrilateral, right, you just pick a corner and then go in a circle. So I'm going to pick the bottom left corner, call that A, and then B, and then C, and then D. Right? So in this picture, the opposite sides are parallel. So that means that segment AB is going to be parallel to segment CD. AB is over here on the left, CD is on the right. They're parallel. And segment AD on the bottom is parallel to segment BC on the top. So these are parallel. Use two arrows, right? That's how you show parallel in a picture. So again, if you know it's a parallelogram, or if you know that these opposite sides are parallel, right, then you know it's a parallelogram. So that means that we have a parallelogram. Notice I use a little symbol, parallelogram, A, B, C, D. Okay, so instead of writing all that word parallelogram, you can just put that little symbol. Okay, so that is the definition, right? So now, a parallelogram has four more properties that we're going to discuss from, aside from this definition. Okay, so properties of parallelograms. And again, I'll try to keep this up here as much as I can. So properties of parallelograms. And feel free to use the symbol if you want to. They are your notes. So I'm going to draw a parallelogram. I'm going to call it JKLM like this. So we're going to do right here. I'm going to draw kind of tall and skinny, just to kind of give you a different look. Right? So there's my parallelogram, JKLM. And again, you know that the opposite sides are parallel. Okay, so the first property, and let me change colors so that I'm not using green again. So the first property is that the opposite sides, so OPP, opposite sides are also congruent. Right? So they're parallel, that's the arrows, they're also congruent. So JK and LM are congruent, KL and JM are congruent. So JK, segment JK is congruent to segment LM, and segment JM is congruent to segment KL. There we go. Okay, next property, right? So that's the sides. Let's talk about some angles. The opposite angles are also going to be congruent. So in this picture, J and L are opposite angles. They're across from each other, and K and M. And you can name them with 3 letters each or just one letter. I'm just going to use one letter, right? It's easier. So angle J is congruent to angle L, and angle K is congruent to angle M. Okay, one more property about the angles is that the consecutive angles, I'll write that word out, consecutive. The consecutive angles are supplementary, which means they add to 180. Okay, so if J and L are opposite, then J and K are going to be consecutive. They're the ones in a row. So we would know that the measure of angle J plus the measure of angle K is 180. We would know that the measure of angle K plus the measure of angle L, right? K and L are also consecutive, is 180. We would know that the measure, doesn't want to write there. Weird, hold on just a second. The measure of angle L plus the measure of angle M equals 180. And we know that the measure, must be too close to that, measure of angle M plus the measure of angle J equals 180, right? So you have 4 sets of consecutive angles. The reason why this is true is because these consecutive angles are same side interior angles. So if I just quickly draw a little picture here, so again, remember parallel lines cut by a transversal, right? So if these 2 lines are parallel, then these 2 angles are same side interior angles, where these 2 dots are. And that would be the same thing like angle J and K would be those two. Because if I cut off, so if I take this, my eraser, and if I cut off the top, and I cut off this, and I cut off this, and I cut off that, there's your picture. There's your opposite sides of the parallelogram with the side going in between. There's your consecutive angles, which are supplementary. Okay, and then last but not least, right? What if I draw in some diagonals? Now, diagonals go between the opposite angles, so I'll do my best. So J to L and K to M. And let's put their intersection point as point P. Well, in a parallelogram, the diagonals bisect each other. Bisect each other. So we got to remember bisect, right? 2 congruent parts. 2 congruent parts. So in this picture, JL is split into 2 congruent parts, JP and LP. So I know that JP, segment JP, is congruent to segment LP. I also know that KP and MP are congruent. So segment KP, let me see if I move this, sorry. Put up here. Segment KP is congruent to segment MP, right? Now, what that means is for both of these, P is the midpoint of both segments, P is the midpoint of JL and KM, your 2 diagonals. So keep that all in mind. Okay, so there are your properties of parallelograms. So again, your job on the practice is to apply these properties and solve some pretty basic problems. All right, good luck.